All right, welcome back to Mr. PLs with Algebra 2, Units 5, SLT6. What we have here is basically a review of all of our SLTs. Warm-up says, find the following. What's the probability of being in E? So there's 2 people in E out of 4, 5, 6, 7, 8, 9, 15. Probability of being in M, so that would be, let me go back for a second. So probability of being in E, it's not just these 2, but also these 6, because these 6 are in circle E, so that's a grand total of 8. Sorry, I almost missed that. And probability of being in M is 6 plus 3 makes 9 out of 15. Let me move myself. Probability of being in E or M would be all of these. 6, 9 plus 2 more makes 11 out of 15. Probability of being in both would be 6 out of 15. Remember, this is an intersection, which is like an and this is a union, which is or. And the probability of not being in E would be these 2 categories, which would be 7 out of 15. All right, according to a credit card company, gives the following information. 42% of its customers are classified as long-term cardholders. I'm going to do this out of 1,000 like I have been. 35% pay their bills off each month in full, so that's $350. 23% are both, so that's 230 go here. So I can use simple subtraction to get this is 120. 420 minus 230 makes 190. All right, so this is the given that section. So what is, by the way, this is out of 1,000, so I do need to figure out how many are on the outside. So minus 190, minus 230, minus 120. That's a grand total of 460 people that are in neither of those 2 categories. So what's the probability of being a long-term card holder given the fact that we know that they pay in full? So we know it's out of the 350. How many people are also long-term card holders? That would be the people in the middle, so that'd be 230. Of the people in this circle, 230 of them are also in the L circle. Now, this looks like the same question, but it's not. Is the probability of being a full, paying in full, given the fact that you know that they are long-term card holders? So it's out of 420, and once again, that's 230 out of that 420. So it's out of a different number. So conditional probability of A over B is the intersection of the 2 categories over the total of whatever B in this case happens to be. All right. When a room is randomly selected in a downtown hotel, the probability that the room has a king-size bed is 62%. So that's 620 out of 1,000. Room has a king-size bed and has a view. So king-size bed is 620. Probability it has a view is 430. Probability it has both would be 380. So simple subtraction. And find that this is 240. 430 minus 380 gives me 50 over here, and then whatever's left over is on the outside. So what is the meaning of probability of A given the fact that B occurred? So if A is the event that king-size bed, so what's the chances of you being in this circle given the fact that we know you're in this circle? So it's out of 430, and it would be this 380 because these people are in circle A given the fact that we know they're in circle B, so it's out of 430. Just did that. So are the king-size bed okay, so are they independent or not? So if the probability of A is the same as the probability of A given the fact that B occurs, then they are independent events, meaning it does not matter whether or not B happened or not. So if A is 620 out of 1,000, so that's 62%, and this over here, 380 divided by 430, is 88%. So this is not independent. All right, so if you roll a 6-sided number cube, then flip a coin. So you can get a 1 and a heads, you can get a 1 and a tails. So this is just for your sample space. 2. All right, so there's your 12 possible outcomes that can occur. Calculate the probability of being in A and calculate the probability of being in B. So A was rolling a 4. So there's 2 out of 6. And calculate the probability of being in B. So getting a tails would be 6 out of 12. Or 1/2 in this case. This was 2 out of 12, sorry. Which is a 1 out of 6 chance. Calculate the probability of being in A and B. Well, there's only 1 out of 12. So are these independent events? So the probability of A occurring should be the same as probability of A occurring given the fact that B occurred. So given the fact that I know I got a tails, the chance of getting a 4 is 1 out of 6. And the chance of rolling a 4 to begin with was 2 out of 12, which is also 1 out of 6. So these are independent events because rolling a cube is not going to have anything to do with the die. And let's see, last one. So a number cube has phase number 1 through 6, and a coin has 2 sides, heads and tails. The number cube will be rolled, and then the coin will be flipped. Is then rolling a number cube and flipping a coin independent? Just answered that. Yes, they are. If you toss the coin 5 times, what's the probability that you see heads on all 5 tosses? Well, it's a 1 out of 2 chance on all 5 of those coins. So if you multiply 1 out of 2 5 times in a row, 2, 4, 8, 16, 32. 1 out of 32 chance of that occurring. So pretty unlikely. If you roll a number cube 3 times, what's probably they'll show a 4 all 3 times. So 1 out of 6 on all 3 number cubes. So just because you're rolling only 3 instead of these 5, it's actually going to be a lot less likely of occurring. 6 times 6 is 36, times 6 again is 216. So super unlikely of that occurring, or this is just, I would say, unlikely. All right, I'm going to stop it right there. Thanks again for watching, and please look forward to the next set of videos coming out. Have a great day.